हेलो बच्चों, इस एपीसोड विच तुसी फंक्शंस, डोमेन एंड रेंज ऑफ ए फंक्शन, इनटू एंड ऑनटू फंक्शंस, one and many one functions, relation between relations and functions ਅਤੇ inverse functions ਬਾਰੇ ਜਾਣੋਗੇ। ਆਓ ਹੁਣ ਸ਼ੁਰੂ ਕਰਦੇ ਹਾਂ। Recall the definition of a relation learned earlier, that if A and B are two non-empty sets, then a relation R from A to B is a subset of A cross B. Thus, R is a relation from set A to set B if R is a subset of A cross B. Also, if the ordered pair AB belongs to the relation R, then we write it as A relate to B, which implies that A is in relation R with B. We shall see in due course as to how a function is related to a relation. Function. Let A and B are two non-empty sets, then a rule which connects to each element A belonging to a unique element B of B is called a function from A to B. B is called image of A and A is called the pre-image of B. Thus, a relation R from set A to set B is a function f if every element in set A has a unique image in set B. Thus, no two ordered pairs belonging to the function have their first element same, and it is written as f is a function from set A to set B. For example, if A is the set of 6 solids kept in a row, and B is the set of numbers 0, 1, 2, 3, 4, 5, 6. Since a unique number is associated with the position of solids in the row, so every number of A has an image in B. Thus, the relation is numbered as is a function from A to B. If set A containing elements 1, 2, 3, 4 and set B containing elements 1, 4, 9, 16 and 25, let f be a function from set A to B, and f is the set of ordered pairs of A cross B. That is, f is the set of ordered pairs 1, 1, 2, 4, 3, 9 and 4, 16. Then the set A is called the domain of the function and set B is the codomain, and set containing elements 1, 4, 9, 16, which are the second element of the ordered pairs, is known as the range of function f. Let us now discuss the different types of functions. Consider a function f as is a national flag of from the set N of national flags of South Asian countries to the set O of all South Asian countries. Since every country has its unique national flag and two distinct flags will be associated to two distinct countries, so there is 1:1 correspondence between each flag and its corresponding country. So a function is 1:1 or injective if distinct element of domain A have distinct images in its codomain B. A function f from set A to set B is 1:1 or injective if distinct elements of set A have distinct images in set B, implies if A1 is not equal to A2, then f of A1 is not equal to f of a2 for all a1, a2 belonging to set A, or if and only if a1 is equal to a2 implies that f of a1 is equal to f of a2 for all a1, a2 belonging to the set A. Let f is a function which can be defined as has number of faces from the set A of solids like cube, cuboids, tetrahedron, cylinder, cone and sphere to the set B of numbers 0, 1, 2, 3, 4, 5 and 6. Then two solids, cube and cuboid in the domain of A have 6 faces each, so they have only one element as image in the codomain B. Such a function f from A to B is said to be many one if two or more than two elements in set A have the same image in set B. Again, consider function f as is a national flag of from the set N of national flags of South Asian countries to the set O of all South Asian countries. Then any element in the codomain O being a country must have its national flag, that is, every element of set O will have a unique pre-image in set N. Thus, if every element in codomain has a pre-image, then the function f is said to be an onto or surjective function. For such a function, the range of function is equal to its codomain. Thus, function f from set A to set B is onto or surjective if for every B belonging to set B there exists an element A belonging to set A such that f of A is equal to B. Consider again the function f defined as has number of faces from the set A of solids like cube, cuboids, tetrahedron, cylinder, cone and sphere to the set B of numbers 0, 1, 2, 3, 4, 5 and 6. Then cube and cuboid both are associated to numbers 6, cylinder to 2, sphere to 0, cone to 1 and tetrahedron to 4. Thus, there is no solid in the domain of set A which is associated with numbers 3 and 5 in the codomain. Thus, a function from set A to set B is said to be into if there exists even a single element of set B having no pre-image in set A. Consider the function f as is a national flag of from the set N of national flags of South Asian countries to the set O of all South Asian countries. Then for each national flag there exists an associated country and corresponding to each country there is a national flag belonging to it. Thus, there is 1:1 correspondence between elements of domain N and codomain O. If the function is both 1:1 and onto, then the function is called the bijective function. For a bijective function, the number of elements in domain and codomain are equal. If graph of a curve is given, then how to determine whether it's a function or not? Consider the equation y square is equal to 8 times x. Two of the points lying on the curve are 2, -4 and 2, 4. They have their first element same, so the relation y square equal to 8x is not a function. Again, when we join the points 2, -4 and 2, 4, we get a line parallel to y-axis, that is a vertical line. Thus, if a vertical line can be drawn intersecting the graph of a function in more than one point, then it's not a function. Next, we define invertible function. Let f is a function from set A to set B. If there exists a function g from set B to set A such that f of x is equal to y, implies that g of y is equal to x for all x belonging to set A and all y belonging to set B, then function f is an invertible function and the inverse of f is g. It is written as f inverse is equal to g. Some properties of invertible functions are: sets f and g are said to be inverse of each other. Clearly, a function is invertible if and only if it is 1, 1 and onto. Again, it can be shown that an invertible function has a unique inverse. As the name suggests, inverse of a function f is function f itself. ਹੁਣ ਤੱਕ ਤੁਸੀਂ functions, domain and range of a function, into and onto functions, many one and one functions, relation between relations and functions ਅਤੇ inverse functions ਬਾਰੇ ਜਾਣਿਆ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕਰੀਏ। Now let's see an example. Which of the following relations are functions? Give reasons. In case of a function, find its domain and range. First, f, which is the set of all the ordered pairs such as 1, 3, 1, 5, 2, 3 and 3, 5. G, which is the set of ordered pairs 2, 1, 5, 1, 8, 1 and 11, 1. And H, which is the set of ordered pairs 2, 1, 4, 2, 6, 3, 8, 4 and 10, 5. Now its solution. For first, here the given relation is f, which is the set of ordered pairs 1, 3, 1, 5, 2, 3 and 3, 5. So in f we find that ordered pair 1, 3 and 1, 5 have the same first element, that is 1, because ordered pair 1, 3 and 1, 5 have same first element, that is 1. Which implies here 1 has 2 images, that is 3 and 5. Under relation f, so we can say that f is not a function because we know that every element of a function has unique image Here f is not a function. Now for the G, which is the set of ordered pairs 2 1, 5 1, 8 1 and 11 1. Here no two distinct ordered pairs in G have same first element so G is a function. So therefore domain of G is the set of all the first elements of all the ordered pairs in G, that is, it is the set containing elements 2, 5, 8 and 11, and range of G is the set of second element of all the ordered pairs of G, that is 1. So range of G is the set containing element 1. Now third, H, which is the set of ordered pairs 2 1, 4 2, 6 3, 8 4 and 10 5. Here no two distinct ordered pairs have same first element so we can say that here relation H is a function so here domain of H will be the set containing all the first elements of ordered pairs, that is, it is the set containing elements 2, 4, 6, 8 and 10, and range of H is the set of all the second elements of the ordered pairs of H, that is, it is the set containing elements 1, 2, 3, 4 and 5. So here H is a function with domain as set containing elements 2, 4, 6, 8 and 10 and its range is the set containing elements 1, 2, 3, 4 and 5 जो कि ਅਸੀਂ पता करना ਸੀ. Now let's see another example. Find the domain and range of the function defined by f of x equal to 1 by x minus 3. Now its solution. The given function f defined by f of x is equal to 1 upon x minus 3. So here function f is not defined at point x equal to 3, but function f is defined on all the real numbers except 3. So we can say that domain of the function f is the set of real numbers except 3. Now let y is equal to f of x, which is equal to 1 upon x minus 3, implies that x minus 3 is equal to 1 upon y, implies that x is equal to 3 plus 1 upon y, further implies x is equal to 3y plus 1 upon y. So therefore x is not defined when y is equal to 0, implies that x is defined for all values of y except y equal to 0. Therefore, range of the function f is equal to set of real numbers except 0. That is, the range of the given function f will be all the real numbers except 0. Therefore, for the given function f, defined by f of x is equal to 1 upon x minus 3. The domain of the function f will be set of real numbers except 3, and range of the given function f will be set of real numbers except 0. जो कि ਅਸੀਂ ਪਤਾ ਕਰਨਾ ਸੀ। ਹੁਣ ਤੱਕ ਤੁਸੀਂ functions, domain and range of a function, into and onto functions, one and many one functions, relation between relations and functions ਅਤੇ inverse functions ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕੀਤਾ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਹੋਰ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕਰੀਏ। Now let's see another example. Show that the function f from the set of natural numbers to the set of natural numbers such that f of x is equal to 4x plus 3 is an injective function. भाव ए दर्शाओ फंक्शन f जो कि सेट ऑफ नेचुरल नंबर्स तो सेट ऑफ नेचुरल नंबर्स तक इस तरह डिफाइंड है कि f of x बराबर 4x जमा 3 एक इंजेक्टिव फंक्शन है। नाउ इट्स सॉल्यूशन। Here the given function f from the set of natural numbers to the set of natural numbers such that f of x is equal to 4x plus 3. Let x1 and x2 be natural numbers. Now f of x is equal to 4x plus 3. Therefore, f of x1 equal to f of x2 implies that 4x1 plus 3 is equal to 4x2 plus 3. Further implies 4x1 is equal to 4x2 implies that x1 is equal to x2. So this implies distinct elements in the domain N have distinct images in codomain N. Thus, we can say that function f is injective or one function because every element in its domain N have distinct image in its codomain N. So function f is injective or one function. ਤਾਂ ਇੱਥੇ ਦਿੱਤਾ ਗਿਆ ਫੰਕਸ਼ਨ f ਇੰਜੈਕਟਿਵ ਜਾਂ 1 ਫੰਕਸ਼ਨ ਹੈ ਜੋ ਕਿ ਅਸੀਂ ਦਰਸਾਉਣਾ ਸੀ। Now let's see another example. Show that function f from set A to set B is an into function such that f of x is equal to x minus 2 where set A is the set containing elements 2, 3, 5 and 7 and set B containing elements 0, 1, 3, 5 and 7. Now its solution. Given function f from set A to set B such that f of x is equal to x minus 2, where set A containing elements 2, 3, 5 and 7, and set B containing elements 0, 1, 3, 5 and 7. So here f is an into function if there exists even a single element in codomain B having no pre-image in domain A. Here f of x is equal to x minus 2, then f of 2 is equal to 2 minus 2 equal to 0, f of 3 is equal to 3 minus 2 equal to 1, f of 5 is equal to 5 minus 2 equal to 3, and f of 7 is equal to 7 minus 2 equal to 5. Thus, every element in set A has an image in set B, that is, for 2 belonging to set A, 0 belongs to set B. For 3 belonging to set A, 1 belongs to set B. For 5 belonging to set A, 3 belongs to set B. And for 7 belonging to set A, 5 belongs to set B. Now, we see that there exists an element 7 belonging to set B having no pre-image in set A. Therefore, we can say that function f is into function So here range of function f is equal to the set containing elements 0, 1, 3 and 5 and codomain of function f is the set containing elements 0, 1, 3, 5 and 7, which is equal to the set B. Therefore, we can say that range of function f a subset of its codomain that is equal to set B ਤਾਂ ਇੱਥੇ ਦਿੱਤਾ ਗਿਆ ਫੰਕਸ਼ਨ f ਇਨਟੂ ਫੰਕਸ਼ਨ ਹੈ ਅਤੇ ਇਸ ਦੀ ਰੇਂਜ set B ਦਾ ਪ੍ਰੋਪਰ ਸਬਸੈਟ ਹੈ ਜੋ ਕਿ ਅਸੀਂ ਪਤਾ ਕਰਨਾ ਸੀ। ਇਸ ਐਪੀਸੋਡ ਵਿੱਚ ਤੁਸੀਂ ਸਿੱਖਿਆ ਹੈ definition of a relation if A and B are two non-empty sets, then a relation R from A to B is a subset of A cross B. Thus, R is a relation from set A to set B if R is a subset of A cross B. Also, if the ordered pair AB belongs to the relation R, then we write it as A relate to B, which implies that A is in relation R with B. Here, if set A containing elements 1, 2, 3, 4 and set B containing elements 1, 4, 9, 16 and 25, let f be a function from set A to B and f is the set of ordered pairs of A cross B, that is f is the set of ordered pairs 1 1, 2 4, 3 9 and 4 16. Then this set A is called the domain of the function and set B is the codomain and set containing elements 1, 4, 9, 16 which are the second element of the ordered pairs is known as the range of function f. A function f from set A to set B is 1 1 or injective if distinct element of domain A have distinct images in its codomain B. Many 1 if two or more than two elements in set A have the same image in set B. Onto or surjective if every element in set B has at least one pre-image in set A. Thus, a function f from set A to set B is onto or surjective if for every B belonging to set B there exists an element A belonging to set A such that f of A is equal to B into function if there exists even a single element of set B having no pre-image in set A. Bijective if the function is both 1 1 and onto. ਇਸ ਐਪੀਸੋਡ ਵਿੱਚ ਤੁਸੀਂ functions, domain and range of a function, into and onto functions, 1 1 and many 1 functions, relation between relations and functions ਅਤੇ inverse functions ਬਾਰੇ ਜਾਣਿਆ ਹੈ। ਉਮੀਦ ਕਰਦਾ ਹਾਂ ਤੁਹਾਨੂੰ ਐਪੀਸੋਡ ਪੂਰੀ ਤਰ੍ਹਾਂ ਸਮਝ ਆ ਗਿਆ ਹੋਵੇਗਾ।